Dealing with the area of regular polygons today, but there are certain pieces of polygons that we need to identify and see how to find before we start worrying about finding the area. And when we get into this, you're going to realize why I waited until after exams to start teaching this. It's just a lot of stuff. Okay? All right, well, the first thing you need to know is when we are talking about a regular polygon, let's refresh our brains. What does it mean to be regular?
All the sides equal.
All the sides equal each other and
Angle.
all the angles equal each other. Okay? We're going to learn about the center of a regular polygon, the radius of a regular polygon, apothem of. Do you get that part now? That's why it says of a regular polygon. So I didn't have to write it over and over again. Okay? All right. Any regular polygon can be inscribed in a circle, which means you can draw a circle around it and it will touch all the vertexes, which we would call vertices. Because of that, that helps us to recognize a couple of the things that we have up here. The first thing is the center. Because the center of any regular polygon is the center of the circle that is circumscribed around it. So in this specific hexagon, the center would be approximately right there. Okay, now I'm just eyeballing it, so it's pretty close. Now, a polygon also has a radius. We're not always going to see the circle around our regular polygons, but we need to understand that it's there. So let me ask you something. If the center of the polygon is the center of the circle, and the vertex of the polygon sits on the circle, where do you think we would draw the radius of a polygon?
The vertex to the center.
From the center to a vertex. Any vertex. All right, so specifically, this would be a radius. And since it's inscribed in a circle, the radius of the circle is the same as the radius of the polygon. Now, how many radii would a polygon have?
It's number 6.
This one would have 6 because it has 6 angles. An octagon would have 8 because it has 8 angles. Okay? So, that's why we draw the circle, to help us identify the center and the radius. Now, the apothem is something new. I have it in green, and I'm going to draw it in green. But the apothem is a segment from the center of the polygon to the side. But it does something very specific to that side. Not only does it bisect it, it's perpendicular to it. Okay? So an apothem is the perpendicular bisector of any side of the polygon. Just depends on where you draw it. Right. Okay? But don't get caught up in all the circle terminology. Because when we're drawing our pictures, we're not going to draw the circle around it. This is just to help us get acquainted with why do we call it a radius? Why do we call it the center? Because it's very, because of the circle. And then finally, we have a central angle in a polygon. And a central angle is formed by 2 consecutive radii. It's written in blue. I'm going to draw 2 in blue. All right? Let me customize my lines first. Okay. This, for instance, would be a central angle of the polygon. Why do you think we call it a central angle?
Because of the vertex.
Because it's also a central angle of the circle. Okay, so the terminology is overlapping. All right. The central angle of a polygon is the key to a lot of the questions that we're going to need to answer. Okay? So the first thing we're going to do is we're going to start looking at how do we use this information. Okay. Up here I have a square, which is a square, a regular polygon. It's 4 equal sides, 4 equal angles. So yes, it is inscribed in a circle. You don't have to draw the circle around it. And I have identified 4 what? Radii. 4 central angles are also identified, and the little green line is the apothem. Okay. Now, let's take the apothem out for a second. Oops. Okay. Let's just move him over there. Okay. What do these 4 central angles form?
180 degrees.
All of them put together form a circle. Don't they? Okay. Because this is a regular polygon, every one of those central angles is equal to each other. So a 4-sided figure has 4 central angles that add up to a circle, which is how many degrees? 360 degrees. So in this specific polygon, that means that this is 90, this is 90, this is 90, and so is this. So how do we find the central angle of a regular polygon? You divide by the number of sides. A 4-sided figure has 4 central angles. A 6-sided figure will have 6 central angles. Okay? All right. That's good. Now, oh, I didn't think they'd all be connected. Let's focus on this triangle here. What do we know about this and this?
They're
congruent to each other. So we have an isosceles triangle. So if that is an isosceles triangle, when I come and put my apothem in place, it's the altitude. So what does it do? It bisects the side. It is perpendicular. And what does it do to this 90-degree angle? It bisects the angle. Okay? Now, what you see here is that we're not leaving all of the right triangle stuff that we've been using. We're still going to need it. All right? Pretty much we're not going to be using much of the Pythagorean theorem. It's mostly going to be special right triangles and sine, cosine, and tangent. All right? Every once in a while you might have the Pythagorean theorem. But it's the more detailed stuff that we need. Okay. What kind of a shape is this? I want a specific name.
Hexagon.
It is a hexagon, which means it has 6 sides. And I'm telling you it's regular. So that's important because none of this works if it's not regular. Okay?
Are they going to tell us it's regular in homework and stuff?
Well, and we're dealing with regular polygons.
Alright.
All right. Now, whenever we're going to find the information that we need about these regular polygons, we basically need the shape itself. We need to identify one radius, one apothem, and this information will be used to help us figure out what? A whole side. Okay? So this little piece